today's lesson, we'll be covering alarming configuration and then also some of the standard alarms in our Danfoss pack controller as part of our AK PC training here. So for alarming of our pack controllers, there are two areas where the alarms will typically appear that a technician may be looking at to troubleshoot, investigate, and then also for the notification itself. One area is directly in the pack controller itself. So with a technician that has a computer tied directly into the pack controller using Service Tool, there is an alarm log that you can go into. At the bottom of your overview screen is an alarm button that you can click on. It's like the alarm bell that we have here next to our service wrench for configuration. And this gives us two pages in that screen. One is for active alarms that will timestamp and show us any current alarms that are still a problem. And then you'll also get a second page for cleared alarms that we can go back and check for maybe nuisance alarms that are retriggering at a high rate. That may be a good indication of a problem that needs to be investigated further as well. So both active and cleared alarms we can see from the pack controller. And then the second area is through the system manager itself. So we know in most installations that the pack controller will be tied back to a system manager for communication. The alarms that are generating in the pack controller are transmitting back to the system manager if configured properly, so that those alarms can then be transmitted out to something like a monitoring service provider or end user, so that they can be notified of those alarms if they need to dispatch a technician or just to maybe remotely connect to the store and do a little investigation. The second area that you'll see the alarms displayed is through that system manager. So our goal today is to go through and give examples of some of the most common alarms that you'll expect to see in the pack controller, what they mean, maybe a little bit of how to investigate and troubleshoot them. And so we'll just go through some of these individually one by one. We'll start here with the main switch alarm. So you'll see one alarm that could potentially pop up in your system is this verbiage that you see at the top right that says control stopped, main switch equals off. And so this main switch off is significant because it does mean that the rack has been disabled. So compressor operation is off, high pressure valve, receiver bypass valve, these things have all been forced closed. So your pressure will be building up in the system in theory without any electronic control to resolve that and potentially blowing a relief valve. So there's two places that the main switch can typically be disabled to generate this alarm and shut down the rack. The first is that there is a setting that we covered early in session 1 called the external main switch. That external main switch parameter gives us a digital input that a device is expected to be wired to. And when that external main switch contact is open, that tells the pack controller that it thinks that the rack is down. So for that external main switch, that typically being wired to that phase loss monitor, there's a couple things there. One is there could be a true phase loss, and we are taking the rack down as intended, and we don't want to run it. It could also be that the phase loss monitor is bad. So some troubleshooting if we know that we do have proper power into the building, and maybe we just need to override the phase loss monitor to do some testing to see if it's just a bad phase loss monitor. If we're looking at this during the startup phase, it could be that the phase loss monitor is wired incorrectly. The order of the phases at the top of the device could be wired in the wrong order, and I've seen that generate the main switch off because the phase loss monitor actually interpreted that incorrect wiring as a phase loss as well. So just some troubleshooting that may have to happen there. The second area that can generate the main switch off alarm is through the user parameter that's available in the pack controller. So under our lock unlock configuration section of your configuration menu, you have the main switch parameter. While that's in an on state, you're telling the pack controller that it's okay to carry out its normal logic. If a user turns this to an off state, this setting, then they are disabling the rack there. And so they may be doing that intentionally for some service reasons. There are some prompts that we see throughout the pack controller if someone is trying to change a drastic setting. And so something, number of compressors, changing the application from a booster system to a single suction group, things that are outside of just a smaller set point change. These larger changes will prompt the user to disable the main switch. And so just good to keep in mind that if you're saying yes to that, if you're turning this off in general, it can also be done from the system manager, that we are making sure that that's not for an extended period of time unless we know exactly what that change entails, because that will, again, disable the rack and will potentially lead to relief valve releasing CO2 from the system if pressures build up for too long. We'll jump into our compressor area now, and we will start to see usage in the alarms of some of the abbreviations that we had talked about back in session 1. And so if you recall, under our configuration for the suction group, we had some settings that were linked to high discharge limits, so discharge temperature, discharge pressure here. And then we have some things on the low side of the system with suction pressure limits and also superheat limits. And these would apply for both your medium temp and your low temp suction groups. So these alarms, these thresholds, and then also on the right side, your digital inputs that may be coming from some sort of mechanical protection, thermal overloads, oil pressure regulators, pressure switches, these things generating individual shutdown signals for the compressors as well. All these things are going to generate alarms in the pack controller. And so it's good to remember where these settings are, and then to also be able to tie the alarm back into the setting so that we know if part of the troubleshooting needs to be considering if the setting that we have in for, let's just say, SD max limit is potentially too low and we need to look into raising that value some. So we'll get into some of those individual alarms now, one by one. We'll start off on the low side of the system. So the 2 alarms that you could potentially see tied to suction pressure would be high pressure PO, low pressure PO, where PO again represents suction pressure transducer. XX here at the top of the screen, this is just meant to signify that could be medium temp or low temp. So the actual readout of the alarm that you'll see in the controller would be high pressure PO MT or high pressure PO LT, depending on which suction group has that high alarm or high suction condition. For high suction, the alarm itself is just a notification. So the pack controller is already trying to run all the compressors that are available that aren't already locked out to bring the suction pressure back down. So there's really no additional action to take directly at the rack. What action will be taken that isn't directly tied to the high suction pressure, but is somewhat related, is if we go back into our medium temp suction groups program, under the final page of our suction group configuration, and this is going to be the same for low temp or medium temp as well, but there's the setting for injection on. And if you recall some of our conversation back in lesson 1, that injection on signal is meant to disable the expansion valves down at the case controllers when suction pressure gets too high on that suction group. And so while the high suction pressure alarm itself isn't triggering this action to begin, it's normally very close, because when we look at what starts the injection signal being disabled to shut down the case controllers and the expansion valves, that's defined down here at the bottom. So our suction pressure set point plus half of the neutral zone plus an additional 3.6 degrees is probably going to put you pretty close to where the high suction pressure alarm setting is. And so you can expect this to happen not too long after a high suction pressure limit alarm is generated. Now, if you're looking to do this calculation to see exactly when that injection signal can go off for a given design, back in our suction area of the program, we have our set point here. We're still under our suction group MT configuration. TO set point was our primary set point for that suction group. And then for the neutral zone, if we go back out to our overview screen, we have the compressor boxes here, the first being for the medium temp group, the second for the low temp. If I click on that first box for medium temp, and I go to my third page up top right here for the status of the medium temp, see I can scroll down here, and at the bottom of the screen is where I can find what my neutral zone setting is, and this is adjustable. But if I'm looking to see what's my neutral zone so that I know how to calculate half of that, to add it in for this injection threshold, then that's where you can find your neutral zone in the pack controller configuration. On the low side now, so if we're in a situation where a low suction pressure alarm would generate, it will come in as low pressure POMT or low pressure POLT. Here, the action taken is directly tied to that alarm, and it is immediately shutting the compressor down for that group. So back in our configuration again for the medium temp suction compressors, on my 5th page over, and the setting that we discussed in session 1 that is related here is this TO min limit. So as soon as we drop in saturated suction temperature below this TO min limit, we're immediately going to shut off all of our compressors on that either medium temp or low temp suction group. I'll just also quickly rehash here that we also have the setting for pump down. So if we stay in that medium temp group and go to our second page, the pump down feature, if you recall, was the setting that allows the group to run a little bit below what our normal set point is. So if I have an 18-degree set point on my rack or for my medium temp suction, then maybe I want to allow it to run down to 10 degrees saturated just to keep the compressor, the lead compressor, running at minimum speed a bit longer. So what we want to make sure in regards to that low suction pressure limit is that we're not setting the pump down at or below the same value that we have over here for TO min limit. So I have about a 10-degree spread. That's pretty good. That should keep us away where the pump down shouldn't run us down into this min limit and create problems. But if you're getting frequent alarms for low suction pressure on one of the groups, it's good to compare that pump down setting versus the TO min limit and make sure they're not too close together or that the pump down isn't actually below the TO min limit. Still on the suction side, so superheat alarms are the next two that we could potentially see. So this can be high superheat or low superheat, and this can be both for the medium temp or low temp suction groups as well. Here, still on the same page where we had our TO min limit. Further down in the configuration of that page, you have your two settings for superheat min alarm, max alarm, and then the alarm delay for either of those two. Drop this from 90 down to 50. So if we were to go below the 15 or above the 50 here with a 5-minute delay, that will generate these two alarms. No action taken directly here. This is notification only. From a troubleshooting standpoint, what we want to consider is for low superheat, it could be something from the case level. So floodback's always a possibility from the case side. That's HFC, CO2, any system type. That's something you always want to take into consideration. But then for the CO2 systems, we know that hot gas dumps and liquid injection are two things at the rack that have an effect on the superheat. So if we're getting low superheat alarms, then we need to look at whether or not the setup of the liquid injection is potentially wrong and needs to be adjusted. Maybe we're allowing it to dump liquid in far too low in the superheat. Maybe the liquid injection valve is stuck open, and we need to look at some things there. And then also maybe the hot gas dump is not set up to turn on early enough, or maybe that's stuck closed and not dumping hot gas in to bring the superheat back up. So really both valves potentially need to be looked at when you're at low superheat, and then the same two valves if you're in a high superheat situation as well. If the hot gas dump is dumping when it shouldn't, if the liquid injection's not coming on when it should to bring the superheat back down, then both of those valves can have an effect on a high superheat alarm as well as a low superheat. We then get into our alarms that will be based off of digital inputs for an individual compressor. So you can see alarms that may say safety cutout, they may say motor protect cutout, oil pressure cutout. It's strictly based off of the configuration in your service tool here and which one of these settings you've said yes to generate a digital input for each compressor in that group. And then the alarming will use that same wording. When you're seeing these types of alarms, thermal safety protections, pressure switches, an oil level regulator that's sending a digital input back to the pack controller for each compressor. These are the types of devices and the areas you want to focus in on, because it could be a true mechanical issue that needs to be investigated further. If we're past the startup phase and you're seeing these and you feel like the mechanical side is actually okay, then your other possibilities could be a shorted wire, something along those lines. Otherwise, if it's during the startup phase itself and you're seeing these right away, then it's always good to double check the polarity that's set under IO configuration in the pack controller. That could be wrong. We could be looking for an open state on the contact to signify a safety shutdown versus a closed state, and we need to reverse that polarity under IO configuration. When the compressors are locked out on these failures, they will be removed from the staging pattern, as you see here. So we will skip over them and just go right on to the next compressor or the next stage in capacity for that suction group. Once that problem's been cleared or resolved, then we will add that compressor back into the group after any cutout delays or restart delays that we have defined in the pack controller's configuration. On the high side of the system, here things are slightly different. We have two alarms, so high discharge pressure, high pressure PC. This can be low temp, medium temp, and then high discharge temperature, which is SD, also low temp or medium temp. For PC max limit, here and you'll see similar on the temperature as well, but for the discharge pressure, we are going to start to take some action even before we hit the threshold. So back on our alarming configuration for the medium temp suction group, you can see the numbers that we have in for high discharge temperature and pressure, 284 and 1500 PSI. So for the PC, the pressure max limit, if you use something like our Danfoss refrigerant tool to convert from pressures to temperatures, yes, we're above our saturated value when we're at 1500 PSI, but we can do a COP conversion in that app that gives us a value that we can expect the pack controller to be looking for when we're 5.4 below at 1500. So for example, in our Danfoss app, if we look at 1500 PSI, that's 109 degrees in our app. If I subtract 5.4 from that, that would be 104.6 degrees Fahrenheit. 104.6 degrees Fahrenheit is about 1407 PSI. So about 93 PSI below the 1500. And so what will we do once the discharge pressure exceeds that 1407? So we'll take a staged approach where we'll initially make sure all the gas cooler fans are forced to a full speed if they're not already there. And then we'll begin to stage compressors off in 25% increments of the total capacity. So if we have 4 equally sized compressors, then we would turn one compressor off to remove 25% of the capacity of the rack. We'll give the system 30 seconds to see if removing part of that load or what that compressor was discharging, to see if that reduction helps bring the discharge pressure back down. If we're still within that range of 1407 up to 1500 in our example, then we'll continue to do that every 30 seconds. If we drop back down below 1407, we'll say, okay, that's great. We can now return to normal control. If we go above 1500, then we won't continue with the staged approach. We'll say immediately that we're now in a safety concern with the relief, and we're immediately going to shut all the compressors off above that 1500 PSI limit. And so while we're in the range 1407 to 1500, it's staged. But as soon as we get outside of that range, it's either back to normal operation on the low side, or we're immediately shutting everything off on the high side above that 1500. Just keep in mind the 1500 is adjustable. It's not necessarily the number you're going to see at every job site. So you'll want to use whatever number is in here in our PT app, and then subtract that 5.4 saturated from that to see what that pressure difference actually is, if this is something you're looking into further. Similarly, on the discharge temperature side, so here the big difference would be that it's a little more of a temperature dead band here that we're looking at. So in our SD max limit setting in the pack controller, we were at 284 degrees. Here, 18 degrees below that value is when we'll start to take the same action. So 268 in our example degrees Fahrenheit is when we would start to do the same staging approach of forcing the gas cooler fans to full speed and then reducing compressor capacity by 25% in 30-second intervals. Same logic here. If we get outside of that dead band, so below it, we'll return to normal operation. Above 284, we'll immediately turn off all of our compressors. Just good to keep in mind here also with specifically with the PC max limit on the low temp side, that your low temp discharge is your medium temp suction. So if you're getting a PC max limit on your low temp compressors, you may find that you end up troubleshooting a problem on the medium temp side of a booster design, because if the medium temp compressors aren't running, then the medium temp suction pressure is climbing, which also means that the low temp discharge is climbing. So just good to keep that booster design in mind, specifically for the low temp discharge pressure, because you may, again, find that your troubleshooting needs to take place with the medium temp compressors as opposed to something on the low temp side. On receiver control, we'll really only have two alarms that we can expect to see, either high receiver pressure or low receiver pressure. So PREC high limit or PREC low limit would be the verbiage that you can expect to see there. It could be one of two situations depending on the configuration. So this could be notification only alarms when we go above the max limit or below the low limit. Or if you recall from our receiver session, there are settings in that receiver configuration area where we can choose to have action taken by the high pressure valve when receiver pressure exceeds the max limit or drops below the min limit. So if we have these enabled, then we will take some actions, just like the settings are intended to do. And the two graphs down below here give you a little bit of a feel of exactly what that action will be and how it's carried out. And so if we're saying we want to close the high pressure valve on high receiver pressure, and we look down here at our graph on the bottom left, you actually get a bit of a dead band here. We call it a P band, and I'll bring our service tool in here just for 1 second again to help support this part of the conversation. So under receiver control, recall we had PREC max setting. So let's just say for our example, we have this at 600 PSI. The other setting that defines this P band or this dead band range is back under set point management of the configuration menu. Under configuration management on the first page here, you can see for PREC max, there's a P band setting here, and it's set in my setup that I'm showing now at 40 PSI. So 600 PSI, 40 PSI. And so what that means is that if we subtract the 40 from that 600, that gives us 560 PSI, which is this left side of this light red or light orange shaded region. And so as soon as our receiver pressure hits that 560 number, you'll see the high pressure valve start to reduce as we get into the middle of that range. As we initially enter that 560 number, the gas cooler fans are going to be overridden to a higher value if they're not already at that value towards 100%. So by the time we reach the middle of the P band, again, for us, it's 40 PSI. So middle of that would be 20. So 600 psi minus 20 psi would put us at 580 here. When we hit 580 psi, our gas cooler fans are probably going to be up at full speed. And then as we continue on from 580 psi up towards the 600, that's when you can expect to see the high pressure valve to be forced towards more of a closed position, or whatever its minimum opening degree is defined as. So that action doesn't necessarily take place right at at 600 psi. Rather, it actually is beginning to do some things as low as 560. And so if you're seeing maybe the high pressure valve is closing off too soon in your mind, or gas cooler fans are running more than you want them to, one possibility here is just that the P band is too large, or maybe your P-rec max is too low, and you might need to consider raising those values a little higher to make that adjustment, and maybe to allow that receiver pressure just to float up a little bit more. Not that we're looking to risk any relief valve issues, but there's some potential there that that receiver pressure can be allowed to get a little bit higher before some of these actions are taking, knowing that those actions start before we actually reach the P band limit. Similarly, on the low side, if we're hitting the P-rec min, we had that at 480 in our configuration. We have a P band here as well. We also have this set at 40 psi in our set point management area. So here we're looking to open the high pressure valve to try to force more CO2 into the receiver to build that pressure back up. And so when we're in this area, the max VHP, or a max high pressure valve opening degree, we have that P band that we're adding in this case. So 480 plus 40 is 520. We'll start to reduce that. We'll start to force that high pressure valve open as that P band is working towards the lower end. So it's actually the subtraction of this. So if we're at a 480 psi limit for our minimum P band, or for our minimum P-rec rather. So if this number is 480 here, and then we have the 40 psi P band, we're subtracting that to put us at 440. And so at 480, we won't do anything just yet with the minimum opening degree of our high pressure valve, but then linearly as we're moving towards 440, we're going to drive that high pressure valve open more and more towards its max limit. And so it's linearly scaled as we're dropping more and more below the P-rec min limit to try to open the high pressure valve up and move that pressure more towards this P-rec min limit, and then eventually our normal set point around 500 or 520. On the gas cooler side, really just one alarm that we can expect here. It's high gas cooler pressure with PGC. So you'll see a PGC high limit alarm. The action that this takes is it's forcing the high pressure valve open. So if PGC goes above the limit that we've defined in the gas cooler configuration, so we're under our HP control area, PGC max 1400. We actually do have a P band, max limit P band here as well, of 50. We'll take similar action here where once we get to 1350, we'll start to close, or I'm sorry, start to open that high pressure valve linearly until we reach 1400. And by the time we hit 1400 psi with the settings we have in place, that high pressure valve should be fully open. The one setting that is indirectly linked here that we want to keep in mind is, and this again is only looking at the high pressure valve, but back under our suction area, we have the safety setting for PC max limit. Typically, these are set pretty close, if not the same value. Here I have 100 psi difference, but it's not uncommon to see both of these values, since they're both looking at the pressures up on the roof at the gas cooler, to be set to the same value. And so if we're getting the PC max limit or the PGC max limit, it's always good to keep in mind that those two are set pretty close to one another, and that it's only the PC max limit that's going to reduce or disable some of the compressor capacity, like we say here. Last slide would just be, what are we doing if some of these sensors fail? If they completely, someone disconnects them, pressure transducers, if someone disconnects the plug connector from it, or the connector has some sort of a failure, or something with the wiring happens, and now all of a sudden we have a sensor that's nowhere near the range we expect it to be. So some different things that'll take place depending on exactly what sensor it is that this is happening to. So for our suction side, and you can see the list on the left, but for the suction side, in this medium temp or low temp, if we lose the suction transducer, then we are going to go into what we call an emergency mode. And so you can see the settings that are linked to this. This is found under the suction group configuration as well. These emergency capacities, and you can have a day and a night if you want separate. It would have to be a schedule that's set up in the pack controller, but you can define a specific capacity that the pack controller will keep the compressors at. So if we go back to our example of saying we have 4 compressors of equal capacity, and we say if we lose a suction transducer on the medium temp, we want to run at 50% capacity, it would keep 2 of the 4 compressors on at full speed to match that. And it would just continue in that capacity, at that capacity and in that mode until the issue with the suction transducer has been resolved. Some of the sensors, there's no actions taken. So our discharge transducers, our suction transducer, or our suction temp sensors as well. So discharge and suction temp sensors, if there's failures there, then no action will be taken on the compressors. We do have, and obviously that would rule out any safeties that we may have in place until that issue is resolved on the discharge side. On the suction side, any of the sensors that we have like this that are being used for a superheat calculation, this means that things like the liquid injection or the hot gas dump are going to be disabled just because we no longer have a valid calculation of superheat. So if we're losing our suction temp sensors, just know that that likely means that we won't have any control of hot gas dump or liquid injection for systems that have that as part of the design. On the high side of the system, if we lose a gas cooler temp sensor, then the fans are being controlled based on our compressor capacity. So your gas cooler fans will just look at whether we're running at 25, 50, 75% capacity or wherever in between we might fall, and staging the compressors to match that capacity, or staging the gas cooler fans to match that capacity rather. And then on our gas cooler pressure transducer, if that fails, the pack controller is actually monitoring the average opening degree from the last 24 hours. And whatever that average opening degree is, we'll just force the high pressure valve to that position and leave it there. Really not easy to get a perfect situation here when we're in these states. Temperatures, pressures, the load itself, the mass flow, the CO2, it just moves so much from minute to minute throughout the system that having something that has to be left static isn't ideal, but there's also not a better way to go about it when you look at the high pressure valve. So looking at this 24-hour average gives us the best chance at trying to keep the rack functional until someone can resolve that transducer problem. And then lastly, on our receiver transducer, PREC, here we'll scale this as well. So this is a calculation internally. It's looking at both the SGC sensor, the gas cooler outlet temp sensor, and your medium temp compressor capacity. And it's running an internal calculation there that's deciding where the best position is for the receiver bypass valve. And so you get a little bit of modulation here. This will move around with that temperature value and the medium temp capacity. So we're not just leaving the receiver kind of in a fixed position, knowing that especially at the receiver, opening degree of that valve is constantly moving under normal situations, and we need to get as close to that as possible while we've lost the receiver pressure reading. Last few things that we want to touch on is with the transmission of the alarming. So 2 things. One on the pack controller side, if we go back into our pack controller configuration, towards the bottom of our configuration list here, there's a setting for alarm priorities. And so for a lot of our alarms that we have that the pack controller can generate, you can see you can get into here if you want to. And if there's some alarms you don't want to generate at all, you can disable them or mark them as log only to only generate in the pack controller. And then you also have low, medium, and high. Now, low, medium, and high have no effect on whether or not the alarm will generate or be passed to the system manager. The only usage of the low, medium, and high for all these alarms, and you can see there's multiple pages to filter through here. But low, medium, and high only comes into play if we go back into our plant type. And in our plant type, you can see there's a setting here to generate an alarm relay if someone wanted an alarm relay on the pack controller for something. And here we can decide if we're going to have that. Do we want that alarm to only trigger on alarms that have been classified as high, or any alarm low, medium, or high, back under that previous page we were just looking at. Final thing we want to touch on here, we have not really gone over the system manager side a ton, but I do want to show, just because of how critical this is, that just having this set up in the pack controller does not mean the alarms will be getting over into the system manager. So in the system manager, we have the overview screen of this configuration, and I'll just get to an area where we can see where the alarms for the pack controller are filtered through. So in our system manager, if we get into our configuration menu here and we go to control, we can see in the program that I'm showing, I have a pack controller. It's our current 782A, latest software version 4.1. So we have that configured in this program. Now, if I go into refrigeration and suction, this is where the pack controller itself is really residing in the system manager. When I say it's residing here, it means this is where we have some visibility to parts of the program of the pack controller, not full visibility. Back to some comments from session 1, but we do have some of this set up. And so specifically for the alarms, you'll see in this area, this setting that we can go into for alarms. And in this area, 11 pages of alarms. So any alarm that the pack controller could potentially generate, whether we're using that feature or not in our application, is irrelevant. This is every possible alarm that the pack controller could generate. You have 11 full pages here, and you can see that by default, those alarms are turned on. So over here, a setting of normal means that those alarms that the pack controller generates, every single alarm will filter through to the system manager to be transmitted out. I'll say most instances we only have maybe about 10% of the alarms that are available in these 11 pages actually turned on. So for a user, one option here would be to disable all the alarms and then go through and turn on just the alarms they want. Here's some examples of some things we've talked about today, like our sensor air for our medium temp pressure transducer. You get further down into this and you can see things like low superheat and high superheat. So you can go through here. If these aren't turned on, or if they're all turned on, you can go through here and just kind of filter it in that way. But it's important when you get into the system manager side of the configuration that you're getting in here and double checking that all the alarms aren't just set to disabled, because even if you've done everything perfectly in your pack controller and you come over here, if these are all set to disabled, then none of the alarms will appear in the system manager and nothing will dial out. So very important here that we're looking at both sides of this solution and making sure that the system manager is also configured to pass or filter through the alarms that we do want to generate in the system manager for notification to technicians. Hopefully that gives you a better feel for the types of alarms you can expect to see in our pack controllers, what causes them, maybe how to troubleshoot them some. So thanks for joining today's lesson, and we will see you on the next one.